Welcome to today's webinar. My name is Tyler Reid. I'm the Manufacturing Applications Manager here at GoEngineer. And today's webinar topic is my top 10 tips and tricks for SOLIDWORKS CAM. SOLIDWORKS CAM is a relatively new product to the SOLIDWORKS family, but it's an old product to us at GoEngineer. SOLIDWORKS CAM is powered by CAMWorks, a tool that we've been using and selling and training for close to 2 decades now. And we've developed a pretty good feel for how to get the most out of the tool, especially to new users. And that's kind of what I wanted to share today, are my top 10 things to get the most out of SOLIDWORKS CAM starting out. I'm going to be jumping back and forth between the PowerPoint and the software as we go along. This is also being broadcast or recorded, and it will be available later on. So if you don't catch something the first time around, definitely check out our YouTube page in a couple days, and it will be back up. So my number one trick is learning how to save operation plan. SOLIDWORKS CAM as a tool comes out of the box with a good amount of functionality, but it can be improved. SOLIDWORKS CAM likes to learn from the programmers, how we want to machine our parts on our machines and our tools. And so SOLIDWORKS CAM really wants us to teach it what we want. One method is called saving operation plan. This allows us to essentially make SOLIDWORKS CAM work for us. We teach the TechDB how we want to treat certain features. The TechDB therefore captures our best practices for these features and allows us to program our parts faster and minimize mistakes and scrap and essentially program the features as well as we think we can without having to retain a lot of information on our own. So in order to do that effectively, we have to understand what we are saving and how to edit it, and learn how the TechDB is structured and the logic that goes behind the TechDB. So let's jump into the software. So what I have here is a little rocker arm, and I've programmed one circular pocket. And on that circular pocket, I have 3 operations. The first one is a contour mill that has a ramp angle to it. So we're doing a circular interpolation down the hole. And then I follow that up with a second contour mill that's finishing the walls. And then I have a third contour mill that is chamfering that top edge. This is how I want to machine this type of feature on this particular part. And so I programmed it that way. That makes sense. But what happens if I want to use this 3-step process later on in the future for a similar type of feature? Well, I can teach CAMWorks or SOLIDWORKS CAM how to retain this feature. So I'm going to use Save Operation Plan. I'm going to go back to the feature tree and right-click on my feature and select Save Operation Plan. It's going to ask, do I want to create a new entry in the database, a new feature condition, or overwrite the existing entry? Now in this case, I want to create a new condition because I want to give it a new strategy name. So by selecting Create New and selecting New down in the lower field, I can give it a new name that's something like 3-step interpolation finish, whatever's descriptive to me. And I don't want to set it as the default. Now I have saved all 3 operations as a strategy, and I've saved it in particular to a circular pocket that is blind in aluminum, which is my current stock material. And this circular pocket will have to be between 0 and 0.3752 inches in diameter, and between 0 and 0.174 inches in depth. Now I can override these numbers, which would allow me to use it for larger diameter features, say 0 to 1 inch, And then maybe I want to be able to do it for any depth, so I would say maybe 0 to 100 inches. Now I've saved that back to the database. So when I'm confronted with a similar feature, like on the other side here, I can create my feature. It's going to have to be a circular pocket. We'll go down to that depth. And now I have my 3-step interpolation, finish, strategy that's selectable there. So I'm going to go ahead and select that. And when I run it through the database, you'll see I get my 3 operations. Cool. Now, how do I make it useful for, say, materials other than aluminum? Well, I can click into one of these operations, and I'll go to the Feature Options tab, and I'll click on this TechDB ID button. And that's going to take me to the database entry that I created. Once I'm looking directly at the database entry, I can make some overrides. So I'm in entry 1253. If I want to use this for more materials, I could say all. I can also, at this point, change what tools I'm using, what depth of cut, and all of my CAM data. So that's saving operation plan. Tip number 2 is saving defaults. All right, so it's no coincidence that my first 2 tips revolve around teaching the database how you want to machine parts, because I think it's a critical component and one of the great strengths of SOLIDWORKS CAM. Saving defaults is a little bit different. It creates selectable strategies for one operation. It bypasses the tech database, and it works separate from generating operation plan, meaning it can be accessed at any time. Now before, in order to access my saved data, I had to create a new feature, and I had to select my feature strategy at that time. Now, what if there's other things I would like to retain? For example, this contour mill. I'm using a particular tool. In this case, it's a chamfer operation. So I have chamfer machining selected. I have my corresponding length and clearance that I like to use. I may have NC planes or feeds and speeds or lead in and lead out data that I like to use all together. It's a recipe that I enjoy using for chamfering. Well, one thing I can do to make that accessible later on is I can go to the Optimize tab and select Save as Default. And when I save a default, I'm saving all of the CAM data within this one operation minus the tool. So I'm going to save this as a chamfer finish. Now at any point on any contour mill, so let's go into a different contour mill, I can go to my Optimize tab, Load Defaults, and I can load in my chamfer finish. And what that's going to do is it's going to populate all of my tabs with the same CAM data. So you can see my chamfer machining is now activated. It won't change the tool, however. Another common way of using this, now that I have a default saved, is coming back to an existing feature. I don't have to run that through the database. I don't have to generate operation plan. I can manually add operations. So if I manually add a contour mill, it's going to prompt me what tool to select. So I'm going to select that countersink tool. Now this is really easy to overlook, but I can go over to the operation tab and I can select my default from here as well. So here's my chamfer finish operation. So there's 2 ways to teach the database how you want to machine your parts or machine your features. One is going to go through the feature recognition and choose a strategy based on parameters of the feature. That's saving an operation plan. And then saving a default just becomes a user selectable set of CAM data, a recipe, for lack of a better word. Tip number 3 is setting default strategies. So when I run feature recognition, SOLIDWORKS CAM is going to look at the faces of the model and identify 2.5-axis machinable features. And when it finds those features, it's going to assign a default strategy. Now we can override those defaults, and we can also use this default strategies window to bulk edit existing features. So let's jump in. Starting with a fresh slate, I'm going to run extract machinable features, and it's going to identify the machinable features of this part. And what we see over here in the list of features are feature names, say irregular pocket 1, and then in brackets it says rough rest, finish. Whatever's in the brackets, that's the strategy that was selected. Now when I run feature recognition this way, it chooses a strategy just based on what I have set as the default. The default is this rough rest, finish. It's a 3-tool or 3-operation strategy. Maybe I don't want that as my default. So in the SOLIDWORKS CAM toolbar, dead center, we have the default feature strategies button. And by opening this up, I can change the defaults for future parts. So for my irregular pocket, I might change the default strategy to rough finish. It might make more sense for, say, a circular pocket. I'm not really going to have to use rest machining for a circular pocket, so I think the default strategy should just be a rough finish. Now when I hit save to TechDB, that retains my saves. If I don't hit save to TechDB and I hit something like apply, that's actually going to bulk edit all of my existing features. So let's take a rectangular pocket and we'll change that to just finish. And we hit apply and look over here, all of my rectangular pockets changed to finish. I didn't have to individually change those one by one. So I can do 2 things with this window. I can save my defaults for future parts, and I can also bulk edit my existing feature strategies. Tip number 4, customizing the options. I'm a strong believer of customizing the SOLIDWORKS CAM options simply because I'm not a huge fan of the default options. I think it improves the user experience and it allows you to sculpt the experience that you want. One thing to keep it in mind, and I'll show you this in the interface, is that when we are changing options, we can do one of 3 things. We can be just changing the defaults, which would affect future parts. We can change the active document only, which would only affect the part that I currently have open. Or we can do both. We could be changing the defaults and the active document at the same time. So the way we access the options, either the SOLIDWORKS CAM options button in the command manager or through Tools, SOLIDWORKS CAM, Options. Now, I definitely encourage you to go through the options and use the help button to help make sense of some of the options, but I'm going to cover some of the things that I tend to suggest and change myself. So under the General tab, I'm not changing a lot, but I do disable the autosaves within SOLIDWORKS. I tend to use the autosave through the SOLIDWORKS options instead. Under mill features, something I am changing here and there are the feature types that are found when using feature recognition. So there are times where I turn off the part perimeter and the face from being found. The reason why I tend to turn those 2 features off is that when they are found by feature recognition, it will tend to find them too many times. It will add a face and a perimeter feature to any part setup that is created because of other features existing from that direction. If I have a complex part and it's has a lot of holes, a lot of times I'll come in here and just change it so that I'm only finding holes. But for the most part, I keep everything on. Now, if you are telling it to find the part perimeter, you want to take a look at this option here. How should we define the part perimeter? Should it be an open pocket or a boss? If it's an open pocket, it's going to want to machine away all of the stock material. And if it's a boss, it's just going to do a circuit around the part. This hole recognition option is critical. This option is essentially the threshold between what is considered a hole feature and what's considered a circular pocket feature. Holes will tend to be drilled out and pockets will tend to be milled out. So I set this diameter to the largest drill size that I want to use, maybe 3/4 inch, 1 inch, whatever you're comfortable using. And then this minimum included angle is a measure for how complete the circle must be to be considered a hole or a pocket. And I tend to do 270 degrees. I'm not going to be able to go into detail into all of these checkbox options, but for the most part, I keep them all checked. That's going to improve my feature recognition. The display area controls how I'm interacting and how I'm viewing or seeing the SOLIDWORKS CAM UI. One thing that SOLIDWORKS CAM does that CAMWorks doesn't is it creates different colored toolpaths for every type of toolpath. So center drills tend to come in differently than, say, rough mills, which look different than contour mills. And I like to set these all to the same color. So say for rough mills, I like to choose this blue. And same for contour mills, I choose the blue. This is just out of habit. You know, back when I started using CAMWorks, everything was the same color, and that's what I prefer. If you're a new user, you may prefer having the separate colors. Now, where colors do come into play, and I do think are useful, is using colors based on feed rate. So what you can do is you can set up windows for minimum and maximum feed rate and then set the color. This can be used one of two ways. You could use this as a warning for feed rates that are too fast for your machine. So you might set a minimum feed rate of, say, 100 inches per minute up to 1,000,000, whatever, and set that as red. And that way, if you ever see a red toolpath, you know that's going to be too fast for your machine. Other ways you can do it would be, setting feed rates for, 0 to 20, 20 to 60, 60 to 120, etc. Whatever is useful to you. But this will allow you to see changes in feed rates from operation to operation, and also allow you to get a better understanding of maybe what are lead-ins and lead-outs and what is not. I do prefer a line weight of 3. That's become the default. It used to be 1, and I thought that was too thin. Under simulation, we have some sliders for balancing quality versus speed, and we have an advanced rendering option that I tend to turn on that allows our simulation to look a little nicer. And under file locations, the last thing I wanted to talk about was opening up your G-code files automatically in an editor of your choice. So with SOLIDWORKS CAM, we do have a utility called the SOLIDWORKS CAM NC editor. This didn't make my list, but if I wasn't limited to 10 tips and tricks, I would have talked about the SOLIDWORKS CAM NC editor. I definitely encourage you to use it if you don't have another NC editor. I set up my options to open up in the NC editor automatically upon post-processing my code. If you have a different NC editor, you can check this box and then browse to the executable file for whatever editor you plan on using. Now, going back to one of these other tabs, keep in mind this apply to. This is the one of 3 options. If I'm just trying to change the defaults, not my current document, I can have that option. If I'm only trying to change my current document, I have that. And then if I'm trying to do all possible, I have that as well. All right, tip number 5 is assembly mode. And this is one of, I think, only 2 of my tips and tricks that are exclusive to SOLIDWORKS CAM Professional. Assembly mode is going to allow you to incorporate true shape fixture avoidance, and it's also going to allow you to essentially multiply your productivity. You're going to be able to program multiple parts in multiple setups, have multiple work zeros, and be able to accurately display how your machine setup will be. So we use this all the time. This is my preferred way of programming before I actually send a part or a program to the machine, especially if my work holding is going to potentially interfere with my toolpaths. So by accurately displaying my vices, my fixtures, clamps, rotary axes, I'm going to be able to reduce or minimize the amount of mistakes I make at the machine. So here's that part. It's a piston part that we programmed in part mode. And if I was cutting just one of these, and if my fixturing wasn't going to get in the way, I might just send this to the machine as is. But if I have access to assembly mode, I do prefer to pull it into an assembly. Something like this. So by pulling it into an assembly, I'm going to be able to pull in my vise, my talon grips, my soft jaws, whatever I have. I don't have to reprogram the part. All I need to do is tell SOLIDWORKS CAM which parts I want to machine and then import the CAM data from the part file. And it's pretty intelligent. I see 4 instances of the same part here, flipped 180 degrees from each other. And if we start to look at the toolpaths, we can see this roughing only applies to these 2 parts, and it doesn't get applied to these 2 parts because SOLIDWORKS CAM can recognize it can't cut that face on this part. I did not have to program this part 4 different times. I only had to do it once. And then I post one program out for all 4 parts. So that's assembly mode. When it comes time to simulate this, I'll be able to get a full simulation of my entire setup. And I can also do fixture avoidance on a per setup basis. So I come into a setup here. Under fixtures, I have all of my fixturing here, and I can elect to avoid it or not. All right, tip number 6 is tolerance-based machining. SOLIDWORKS CAM is the only CAM tool that will actually interpret design intent through toleranced dimensions. It's a complement to the feature recognition. It works alongside it. And essentially what it does is it chooses a strategy based on any available tolerances in the 3D model. So going back a few slides, we talked about the idea of a default strategy. And I said when feature recognition finds a circular pocket, it's going to assign it a rough finish strategy because that's the default strategy. But this changes that. If that circular pocket has a tolerance window, then tolerance-based machining will choose a strategy based on that tolerance window. So this comes into play right now a lot with whole features. And this is an area of the software that's improving every year version. And I expect it to be very powerful in a few years. Right now, it's still pretty introductory. One cool thing that it does is when it comes to pockets with asymmetrical tolerances, it will machine to the mean. Tolerance-based machining gives us the vehicle or the structure to apply CAM data to a part's geometry that doesn't necessarily work on the geometry, but it will machine the ideal shape or a shape that diverts from the geometry in order to give us the best chance for passing a quality inspection. So let me show you how it works. If I have a part like this with 3D CAM data and 3D tolerance data, either dim expert tolerances or standard SOLIDWORKS tolerance dimensions, what I can do is under the SOLIDWORKS CAM toolbar, if I hit tolerance-based machining, it will open up this new tab, SOLIDWORKS CAM TBM. And this is just a different way of running feature recognition. So it's going to bring up this window and it's going to show me what I can change. And let's just go over a couple examples here. So if I'm in a hole, it's telling me the default strategy is drill, but I have all of these tolerance windows down below here. So if there's no tolerance on this feature, it's going to use the drill strategy. But if it does have a tolerance, then based on the tolerance window, it's going to choose a different strategy, potentially a bore or a ream strategy. So that's what's happening here. So I'm going to go ahead and hit OK. It's going to run the feature recognition and just apply strategies based on tolerance windows. I have it set up to not only run the feature recognition, but also generate operation plan and generate toolpath. So with one click, I actually have all of my toolpath on these parts. It's all nicely sorted. But let's take a look here. So we have this hole here. It has a drill strategy, tolerance window of 30 thousandths. Okay. Hole 3 has a ream strategy. That's a tolerance window of 2 thousandths. So if I had run regular feature recognition, these both would have come in as a drill strategy. But through TBM, this came in as a ream strategy. All right, so tip number 7 is VOLUMILL. And VOLUMILL is the advanced high-speed machining technology that's offered in the SOLIDWORKS CAM professional package. It's high-speed machining where the toolpaths are based on constant tool load. And so what's unique about VOLUMILL is you'll actually see variable feed rates based on tool engagement. This is increasing machine productivity by reducing cycle times. I think 50 to 80% is actually conservative. It varies case by case. It also reduces tooling costs by extending tool life. This is a toolpath technology that's easier on the tools, easier on the machine, and yet, it sounds crazy, but it actually improves cycle time. You can use it on nearly any machine. It doesn't require a high-speed spindle. It doesn't require super rigid setups or machines. Of course, the higher speed your spindle is and the better, more rigidity you have in your setup or your machine, the more you'll get out of VOLUMILL, but it is applicable for everybody. So let's take a quick look at an example part. This is an LS7 adapter plate that I used during a separate VOLUMILL webinar a while back. We're doing our roughing on this part, and we're using VOLUMILL strategy. So if I zoom in here, you'll start to see a lot of swoopy moves. The overall toolpath length is longer than a conventional toolpath, but you can move it much faster. And that has to do with the constant tool engagement. There's no shock loading on the tool. If I double click into this rough mill, we'll take a look at the feeds and speeds tab first. We have the VOLUMILL Technology Expert feeds and speeds calculator built in. And what this allows me to do is choose a material. I can set that material's hardness if I know it. Coatings on my tools, my part holding, poor, better, best, my machine taper, my tool holder type, and then I have a slider for conservative versus aggressive feeds and speeds as suggested by VOLUMILL. Okay. The total cycle time for this roughing right now is 7 minutes and 50 seconds, or 7 minutes and 30 seconds. Okay. Now, if I were to change this to a conventional, say, pocket out, and go and use the library for my feeds and speeds, let's regenerate the CAM data. I'm now looking at 68 minutes. So I believe I went from a 330 inches per minute down to 40 inches per minute. Now, of course, we'll be able to adjust this and fine tune it, but with a conventional toolpath, I'm never going to reach 330 inches per minute safely. But with VOLUMILL, I can, and I've seen machines go faster than that. It's incredible. Even on a small, almost hobbyist level machine, VOLUMILL has its place. The faster the spindle, the more improvement we will get, but I've seen people use this effectively with 5,000, 6,000 RPM spindles. All right, tip number 8 is rest machining. Rest machining is something that's come up already, and we haven't focused on it yet, but it's used to, for the most part, eliminate unnecessary air cutting. This is going to reduce cycle times and make our programs more efficient. A common way of using rest machining is to allow a two-step approach to features that have tight corners or are very deep. So let me show you where rest machining is activated, and we'll discuss how to use it effectively. We have 3 pocket features already here in the feature tree, and they each have that rough rest, finish strategy. They've been run through the database. We'll take a look at the first pocket. So here's the rough. The second operation is rough rest. So that's roughing with a rest machining activated. On the first operation, we're using a 1/2 inch tool. And on the second operation, we're using a 1/4 inch tool. And we're telling it only machine what might have been left over from the first operation. If I double click on this rough mill and we go to the rough tab, this rest machining is where this is handled. So if I were to set this to no and hit preview, we fully machine out the pocket. If I say work in progress, what it allows me to do is select any prior operations to pre-calculate and figure out where there might be leftover material. It also looks at the stock as well. So sometimes we're using rest machining not because there's leftover material in a feature, but because we want to work around and only cut where there might be, say, a more complex stock shape. And then lastly, the previous leftover is another method of rest machining. It differs slightly from work in progress. So what previous leftover does is it says, I'm only going to look at operations that applied to the same feature. Whereas from work in progress allows me to pick and choose what I want to pre-calculate. Sometimes from work in progress on a later operation will help me save some time in the calculation. If I say from work in progress, and then instead of telling it to pre-calculate everything, if I tell it only to calculate what was applicable, that's going to calculate a little bit faster. So don't forget that's there, the rest machining. If you're using 3-axis, it's called leftover. Okay, but it's the same idea. And it's essentially our way of telling SOLIDWORKS CAM, look at where there is material and only put a tool where there is material to cut. Sometimes we'll do it if we have a very deep pocket and we want to cut the first half separate from the second half, or the top half separate from the bottom half. All right, tip number 9, custom tools. I'm not going to go into too much detail here, But SOLIDWORKS CAM does have the ability to use custom tools, both in milling and turning. This is going to allow you to create more accurate simulations for your stock removal. There are two ways of creating custom tools. One is to just customize the stock library tools. And this would be, using the same shape, but adjusting, say, the diameter or the shank diameter or the flute length or the flute number, just customizing library tools and then saving them out as new tools. But you can also create custom form tools. So random shape tools, precise tools, custom ground tools. We do have YouTube videos available to go over these in detail. I have pictured here a lathe tool that's actually a SOLIDWORKS assembly. When it comes to lathe inserts and holders, we can use SOLIDWORKS parts or assemblies. But when it comes to mill custom tools, we need to create those as single revolve features and save those out as a SOLIDWORKS CAM form tool. In the user interface, under SOLIDWORKS CAM, there is a button, a toolbar button to save user-defined tool and holder. So this is not a valid tool, so I'm not going to get a preview here. But if you're interested in doing this, definitely check out our other YouTube videos that cover this. Tip number 10 is I guess it's the third professional tip, and that's multi-axis indexing. So with SOLIDWORKS CAM Standard, we have the ability to program in part mode. And if our parts have multiple setups or we need to be machining from multiple directions, we'll be able to program from multiple directions, but we won't be able to automate, say, a rotary index to index between those. Whereas if we're in CAM Professional, we can program them essentially the exact same way, but it will automatically figure out the A, B, or C indexing for you and spit those out in the G code. So let me show you an example here. We do have, it will work well with setups like you see here with a rotary indexer for a fourth and a fifth axis. Any sort of indexing that you might do, this is going to be able to handle it. So going back to the piston assembly setup, we could be a little bit more elaborate with that, something like this. So we have our subassembly in this case, and then we have that patterned around a tombstone. And in SOLIDWORKS CAM, I've set up my machine for 4-axis indexing, and I've told it the rotary axis is around the y-axis, in this case for a horizontal setup. And what that's going to do is when I go to post my code, I have all of these different setups from different directions. And instead of just moving from one setup to the next with nothing in between, it's going to input or output a B code. B0, B90, 180, 270. If this was a 5-axis setup, it would do a B and a C code or an A and a B code, however your machine is set up. This is really going to go far in turning SOLIDWORKS CAM into a tool that is appropriate for production machining. I know I said this was my top 10 tips and tricks, but I had to include at least one bonus tip, and that is if you are reaching the point where you feel like you're up against the boundaries of what SOLIDWORKS CAM can do, maybe you have CAM Professional and you're using the turning, you're using assembly mode, you're using indexing, but you need a simultaneous 4-axis or 5-axis cut. Or you bought a new machine and it's a mill turn or multi-axis or multitasking machine, or maybe wire EDM. CAMWorks is the solution for that. SOLIDWORKS CAM doesn't end at CAM Professional. You can upgrade to CAMWorks and it's 100% compatible. So if you've gone through and You've saved your operation plans, you've saved your defaults, you've customized your tools, you have your post processors dialed in, but you need to go beyond what SOLIDWORKS CAM can do. CAMWorks will be able to reuse and repurpose all of that customization. Everything's 100% transferable, and it really opens up the door to very complex 9, 10 axis mill turn machines and everything in between. So you'd also be working with the same support people that you were working with here at GoEngineer, and we'll have the same level of training and all of that. So don't ever forget that. SOLIDWORKS CAM, it's a fresh product under the SOLIDWORKS name, but it's a very mature product under the CAMWorks name. So I want to thank you guys for joining and sticking with me here. As always, you can email us at support@goengineer.com or call our support line and ask for a little bit more help learning how to implement that. So I want to thank you guys for joining on this Friday afternoon, and have a great weekend. I'll catch you next time.